Hello student, I am Mrs. Shweta Shailendra Pandare, Assistant Teacher, Vidyapith High School, Kolhapur. Chapter 4, Current, Electricity and Magnetism. Next point, magnetic effect of electric current. Next point, magnetic effects of electric current. In this activity, magnetic effect of current is shown. Let's see. Take the inside tray of an used up matchbox. This is used matchbox. वापरलेल्या काडेपेटीचा box. Place a small magnetic needle inside the tray. In this tray we place, this is the magnetic needle inside that tray. Now take a long connecting wire and wind it around the tray. Complete the electric circuit by connecting in it. So connect this wire. These are the cells, plug key and bulb here. We are connecting this simple circuit, electric cell, plug key and a bulb. Mark the position of magnetic needle. Take a bar magnet near to the magnetic needle. What do you observe? You know student that magnetic needle is indeed a magnet. That is also a magnet. Hence, when that bar magnet is take near to this magnetic needle, it change its direction when a bar magnet is come near. Here is the north pole of this bar magnet. Here is the south pole of this bar magnet. Needle having north pole and here is south pole. Hence, when you take this bar magnet, the north pole, then this south pole is come to here because that the unlike pole shows the attraction and like poles shows the repulsion. So we can see here the change in direction when we kept bar magnet near to this the magnetic needle. Then next question, keep looking at the needle and close the plug key. So this is plug key and this plug key is close position. Let's see here. Here is a point. When we close this plug key, circuit is completed. Hence, close this plug key, the bulb will light up and you will realize that the current has started flowing. When we close this plug key, circuit is completed and current is flow through this circuit and this bulb is lights up. When bulb is lights up, then we realize that current is present in this circuit. Does the magnetic needle change its position? Yes, magnetic needle changes position when magnetic needle shows deflection. Now open the plug key. Does the magnetic needle come back to original position. So this plug key is closed. Now open the plug key. Means this dot shows close. When this dot is not here, the contact between these two ends are break. Hence that position is called that open plug key. Then what happened here? Let's see. When plug key is open, there is no current in this circuit. Hence, magnetic needle come its original position. What will you conclude from this experiment? Let's see. When magnetic field is created, when the electric current flows in the circuit, we concluded that the electric current produce magnetic field around a current carrying conductor. Hence, Christian Oersted made this observation first. Briefly, we can say that when an electric current passes through a wire, a magnetic field is produced around that wire. So, electric current pass through a wire, a magnetic field is produced around that wire, and that is detected by this magnetic needle. In the first activity, we see that the electric current when passes through current carrying conductor, that current carrying conductor produces the magnetic field. Hence, current carrying conductor means wire, and when current is flowing through this wire is also act as a magnet, and magnetic field is produced around this wire. This technique is used to make electromagnet, and that electromagnet is explained in this activity number 2. So let's see. Take a meter long flexible copper wire having resistive coating. So this is a copper wire having resistive coating. Resistive, that is a plastic coating on the wire, that is called resistive coating, and wind tightly on a long iron screw. This is iron screw. Then we wind it tightly to this screw. Connect the two ends of the wire in a circuit as shown in the figure. Also connect an electric cell and a plug key in the circuit. So this is electric cell, this plug key. We join the two ends of wire to this plug key and it's to the cell. So this is a simple circuit, and in that circuit the screw is wind tightly by the copper wire. Now start the current in circuit by plugging the key. So we start this current by plug this key or close the key, and at first we seen that when current carrying conductor having the current, it shows the magnetism. So what we notice here, it will be noticed that the pins or nails have stuck चिकटणे, attract होणे to the tip of the screw. So here this is pin or small nail that attract toward this screw. So why this happen? When the plug key is opened. So see, when electric current flows in the wire, magnetism is produced in coil around the screw, and because of that the screw also attain magnetism. When we start the current, this wire is act as or attain a magnetism, and magnetic field of this wire, we tightly wind this wire to the screw. Hence, this screw also get that the magnetism of this wire, and screw also attain this magnetism. Because of that, these pins are get attracted toward the screw. As soon as the current is stopped, the magnetism is vanishes. When we open this plug key, then current not flow through this wire, and this wire not having the magnetism, and screw also not having magnetism, that magnetism it get vanish. The system of coil and screw is called an electromagnet. You have seen various uses of electromagnet in the 6th standard. Electromagnet are used to produce strong magnetic field useful in scientific research. So by this activity we see the electromagnet. By this activity we learn what is an electromagnet. So if a coil wound around iron screw or iron rod, and a current is passing through the coil with a cell. So here is copper coil wounded to the iron rod, and current is passing through cell or battery. A screw behaves as a magnet as long as there is current in the coil. The system of coil and the screw is called an electromagnet. Let's see the applications or use of electromagnetism in our daily life. In daily life, electromagnet used in electric motor, electric fan, motor car, washing machine, circuit breaker, mixer grinder, computer hardwares, mobiles, MRI scan. Here is electric bell that we use in our home, that we study. Next to these are the speakers. In the speakers also electromagnet is used here. So electromagnet is used. A strength of this an electromagnet can be increased by increasing current producing in the magnetic field. When we want to increase the strength of electromagnet, then we increase the current produced in this magnetic field, and we get a powerful electromagnet, and by this electromagnet we can produce strong magnetic field. Here we study the equipment that electric bell that we use in our home, which is having electromagnet. So let's see construction and working of an electric bell with the help of this diagram. The construction of an electric bell and also the electric circuit. The bell consists an electromagnet, contact screw. Here is contact screw. Iron strip. This is iron strip. Metal striker. This is a striker that fall on this bell. So this striker, and metal gong. This is metal gong. A coil of copper wire wound around an iron piece work as an electromagnet. An iron strip along with striker fitted near it. So this is fitted near this electromagnet. A contact screw touch the strip. This contact screw touch this strip. This contact screw touch this strip. The circuit is closed with the key. This is plug key. The current flows in the circuit when screw is in contact with the strip, and hence the coil become a magnet and attract the iron strip toward it. So let's see here, when this circuit is get completed by close this plug key, current is flowing through this circuit. This iron rod having the current and this wire is also having current, and it become a magnet, and this attract this the iron strip toward it. This iron strip attract toward this the because of this is become a electromagnet, and when this attract toward, then the striker hits the gong that attract the iron strip toward it, and therefore the striker hit the gong. This is attract toward this striker is also fall on this the gong, and then sound is formed here. So the striker hits the gong and the sound is created. However, at the same time, the contact screw lose the contact with strip and the current in the circuit stop. In this situation, the electromagnet lose its magnetism and iron strip move back and come in contact with the contact screw. So when we stop the current, then this the electromagnet is also vanish the magnetism, and that are come in the first position. So when we on the bell, then current is flow here in the circuit. This become electromagnet that attract this iron strip, and this iron strip when attract toward this the striker is fall on this gong, and at the same time sound is created. But when we switch off the button of bell, then they are coming the first position to. In this situation, electromagnet lose its magnetism, because when there is the button off condition, current is not flowing through this circuit, and this the magnetism is vanish, and again these are come in the first position. So screw lose the contact with the strip and the current in the circuit stop. In this situation, the electromagnet lose its magnetism and iron strip move back and come in contact with the contact screw. The electric current is then immediately restored, and again the striker hits the gong by the above process. So again above process, when that the electric current immediately restore and that striker hits the gong. This action repeat itself and the bell rings. So due to the electric iron or elastic iron strip. These are iron strip. Elastic, that is movable iron strips. The making of the breaking of circuit occur alternately and the bell continue to ring and along as key in the circuit is closed. When key in the circuit is closed, then current is flowing in this circuit, and at that same time these are attract this iron strip toward, and this striker is fall on the gong and sound is created. When the circuit breaks, the electromagnet lose magnetism. Here plug is not joined and circuit is break, and electromagnet lose its magnetism. The strip due to loss of flexibility will not return to normal position of contact with the screw. Hence, circuit will not complete and bell will not ring. So, this is the working and also the construction of electric bell, that is use of this electromagnet.